All right, everyone, buckle up, because today we're diving deep into a paper that's going to really get you thinking.
Oh yeah, this one's a doozy. It's all about LLMs that can actually reason, like think things through step by step, not just generate text.
Exactly. We're talking about moving beyond that System 1, thinking that our current LLMs are so good at, those quick, intuitive responses.
Right, and into System 2, which is all about that deliberate, strategic thinking, planning out your moves like a chess grandmaster.
In this paper, From System 1 to System 2, a survey of reasoning large language models really maps out this whole evolution from those early AI systems to the mind-blowing stuff we're seeing today.
It's a wild ride, and the key takeaway here is that researchers are building LLMs that can tackle some seriously complex problems like advanced math, even scientific discovery.
Stuff that we used to think was exclusive to human intelligence, and they're doing it by mimicking that human-like System 2 thinking.
It's like they're giving these LLMs a whole new set of cognitive tools, the ability to plan, to reason logically, to verify their own conclusions.
So before we get lost in the weeds, let's give everyone a quick overview of where this all started.
Absolutely. Gotta give some credit to those OG reasoning systems, like Prolog, those early symbolic logic systems.
Yeah, they were all about those handcrafted rules, very rigid, but they laid the groundwork for what was to come.
Right, and then came those game-changing advancements in things like Monte Carlo tree search, MCTS, and reinforcement learning, RL.
Ah, yes, MCTS. The algorithm that powered AlphaGo, the one that took down a world champion at Go, that was a watershed moment.
It sure was, and it's a core technique for exploring different reasoning paths and figuring out which one leads to the best outcome.
So, they're combining the power of deep learning with these classic AI approaches to create these hybrid LLMs that can actually reason, not just parrot back what they've seen.
Exactly, and what's fascinating is that these reasoning LLMs are surprisingly data efficient, meaning they don't need those massive data sets that we usually associate with deep learning.
That's huge.
Yeah.
Because it opens up a whole world of possibilities for AI development. We don't all have Google-sized data sets lying around, right?
Right. It could democratize access to these powerful AI models, making them more accessible to researchers and developers with limited resources.
Okay, now that we've set the stage, let's get into the nitty-gritty, the nuts and bolts of how these reasoning LLMs are actually built.
Let's do it. The paper lays out 5 core methods, and first up is structure search, which is where MCTS comes into play.
So these LLMs are basically simulating different reasoning paths, just like a chess grandmaster thinking several moves ahead. But instead of chess moves, it's reasoning steps.
Exactly. And they're doing this for all sorts of tasks, from solving math problems to writing code to generating scientific hypotheses.
That's mind-blowing. But how do they learn to choose the best path? The one that leads to the right answer or the most logical conclusion.
That's where reward modeling comes in. And the paper discusses 2 main approaches: outcome reward models, ORMs, and process reward models, PRMs.
So an ORM is like giving a student a grade at the end of a test, while a PRM is like providing feedback on each step of the solution, guiding them along the way.
That's a great analogy, and it turns out that PRMs are much more effective for training these reasoning LLMs, though they're also a lot trickier to implement.
Yeah, I can imagine providing feedback on every single step of a complex reasoning process. That would be a massive undertaking.
It is, but the results speak for themselves. The level of reasoning we're seeing with PRM-trained models is a testament to its power.
All right, so we've covered structure search and reward modeling. What's next on the list of these core methods?
This one is my personal favorite. It's called self-improvement, and it's basically where LLMs learn from themselves.
Hold on, LLMs learning from themselves. Are we talking about AI that can teach itself?
In essence, yes. These LLMs can generate their own training data by exploring different reasoning paths and then using that data to refine their reasoning abilities.
So it's like a feedback loop where the AI is constantly learning and improving on its own, becoming more intelligent over time.
That's the idea, and it's led to some pretty remarkable advancements in the field. We're seeing models that can surpass their initial training and achieve higher levels of reasoning.
This is all incredibly impressive, but I'm curious, how do we even know these reasoning LLMs actually work? How do we measure their performance?
That's where benchmarking comes in, and this paper goes deep into the different types of benchmarks used to evaluate these models. It's not just about multiple choice quizzes anymore.
So what kinds of benchmarks are we talking about? Are they just solving math problems, or are there other ways to assess their reasoning abilities?
It's a whole spectrum, from math and coding challenges to scientific reasoning tasks, even agent-based simulations where the LLM has to interact with a virtual environment and make decisions.
So it's about testing their ability to apply their knowledge in different contexts, not just regurgitating facts or formulas.
Exactly. And what's interesting is that the paper notes that we're actually starting to hit performance ceilings on some of those easier benchmarks.
Meaning, these reasoning LLMs are getting so good that we need to come up with even harder challenges to really push their limits.
Exactly. It's like they're graduating to a whole new level, and we need to design tests that are worthy of their evolving intelligence.
It sounds like we're entering a whole new era of AI, where these models are not just mimicking human language, but actually exceeding human reasoning abilities in certain domains.
That's the exciting part, and maybe a little bit unnerving too, right? We're creating machines that are challenging our own cognitive abilities.
Okay, before we get into the existential implications of all this, let's talk about one final core method that's driving some groundbreaking results. Reinforcement fine-tuning, or RFT.
Ah, yes, RFT. This is OpenAI's secret sauce, and it's all about optimizing the model's reasoning process using a reward mechanism, kind of like training a dog with treats.
So you reward good reasoning and discourage bad reasoning. And over time, the model learns to make better decisions, kind of like shaping its behavior.
Exactly, and the results have been pretty mind-blowing. DeepSeek R1, which was trained using RFT, has shown some remarkable capabilities, like the ability to engage in super long chains of reasoning.
We're talking hundreds or even thousands of steps, right? That's way beyond what we've seen with previous LLMs.
It is, and what's even more intriguing is that researchers are observing these moments of what they're calling aha moments during these long reasoning chains.
Hold on, aha moments. You mean like those flashes of insight that we humans experience when we suddenly figure something out?
It seems surprisingly similar, and it suggests that these LLMs are capable of more than just brute force computation. There's something deeper going on.
So we're not just talking about AI that can solve problems, we're talking about AI that can actually think, at least in some rudimentary sense.
It's a blurry line for sure, and it raises some fascinating questions about the nature of intelligence, both artificial and human.
Well, before we get too deep into those philosophical waters, let's take a closer look at this DeepSeek R1 model. What makes it so special?
Sure, one of the key things that sets it apart is the type of reward system they use to train it. They call it a Verifier Reward.
A Verifier Reward. So instead of relying on human-provided rewards, they used another AI model to act as a verifier, kind of like an AI judge.
You got it. And this verifier model was specifically trained on a massive data set of code, giving it a deep understanding of logical coherence and structure.
So the reasoning LLM is learning to reason by mimicking the logic of a code-savvy AI. That's fascinating.
It's a clever approach, and it's incredibly effective. The verifier model can assess the correctness of each reasoning step, providing much more granular feedback than a human ever could.
And because it's all automated, it allows for much more scalable training. You don't need a team of humans constantly providing rewards.
Right. It's a game changer for RL-based training. DeepSeek R1 is a testament to that, but of course, RFT isn't without its challenges.
Yeah, what are some of the hurdles that researchers are still grappling with when it comes to RFT?
Well, the paper highlights a couple of key issues, like reward saturation, which is kind of like when a student figures out how to game the system.
So they get the right answer, but not necessarily for the right reasons. They're just exploiting the reward mechanism without actually understanding the material.
Precisely. And then there's the issue of unstable long reasoning chains. Those models can sometimes get lost in their own thoughts.
Kind of like going down a rabbit hole of logical deductions, but ending up with a conclusion that doesn't make sense in the real world.
Exactly. So controlling and guiding that reasoning process is a major challenge. We need more robust and stable RL frameworks to address these issues.
This all sounds incredibly complex. How are researchers even measuring the performance of these models, especially with those long multi-step reasoning processes?
That's a great question, and one that the paper really grapples with. There's traditional evaluation metrics that focus on the final answer. They don't really cut it when you're dealing with reasoning LLMs.
So we need a more nuanced way to assess not just whether they got the answer right, but how they arrived at that answer, the whole reasoning process.
Exactly, and that means looking at things like the efficiency of the reasoning, the coherence of the steps, even the model's ability to explain its reasoning, like show your work for AI.
It's like we need to grade the entire thought process, not just the final result, and that's a whole new challenge for AI evaluation.
It is, and it's an exciting area of research because it's pushing us to think more deeply about what it means to reason and how we can assess those abilities in a machine.
It sounds like we're still in those early days of understanding and evaluating these reasoning LLMs, but the potential is undeniable.
Absolutely, and this paper doesn't shy away from highlighting some of those promising future directions for this field. It's like a roadmap for the next generation of AI research.
All right, so lay it on me. What kind of breakthroughs are we potentially looking at? What's next for reasoning LLM?
Well, one area that I find particularly exciting is their application to scientific discovery. Imagine an AI that can help mathematicians prove theorems or assist biologists in designing new drugs.
Wait, are we talking about AI scientists that could potentially make Nobel Prize-worthy discoveries?
It's not outside the realm of possibility, but even beyond those headline-grabbing scenarios, the potential for AI to accelerate scientific progress is immense.
It's both thrilling and a little bit daunting to think about, right? We're talking about AI that could fundamentally change how we understand and interact with the world.
It is, but that's the beauty of scientific exploration. It always leads to more questions than answers, and in this case, those questions are some of the most profound ones we've ever faced.
Well, on that note, I think we need to take a breath and maybe grab a coffee before we dive into the next part of our deep dive.
Sounds good to me. We've got a lot more ground to cover, so stay tuned, folks.
So we just spent a good chunk of time talking about how these reasoning LLMs work, the nuts and bolts, but now I want to talk about what they can actually do.
Yeah. Get into the real world stuff.
Exactly, because you mentioned it earlier, this whole idea of AI accelerating scientific discovery, that's huge.
It is, and this paper really highlights that as a potential game changer.
I mean, you said it yourself. AI that can help prove theorems or design drugs.
Yeah.
That's not science fiction anymore, is it?
It's getting closer all the time. Think about it.
Yeah.
An AI that can just go through tons of scientific papers and spot those connections that humans might miss.
Yeah, like having a superpowered research assistant.
Right. Highlighting the most promising leads, but it goes even further than that,
It does, because these reasoning LLMs, they can help design experiments, maybe even generate hypotheses.
Exactly. And because they're so good at that logical reasoning, they can bring this whole new level of systematic thinking to science, which really complements human intuition.
It's a partnership, not a replacement.
Yeah, exactly.
But I'm curious, are there any real-world examples of this happening already? Or is it still mostly theoretical?
Oh, there are definitely real-world examples, especially in things like math and medicine. You remember alpha geometry, the Google AI that was crushing it at the International Math Olympiad?
Yeah, that was amazing. But wait, that's a reasoning LLM?
Well, it uses this really interesting combination of deep learning and symbolic reasoning, so it definitely fits the bill. And the cool thing is, a lot of the techniques that they developed for alpha geometry, they actually have wider applications in science and engineering.
So it's not just about winning math competitions, it's about pushing those boundaries of what's possible.
Exactly.
What about medicine then? Any breakthroughs there?
Oh, yeah. Diagnosis is a big one. Imagine an AI that can just take in all your symptoms, your medical history, maybe even your genetic information, and come up with a personalized diagnosis.
And maybe even catch things that doctors might miss.
Right, exactly. It's not about replacing doctors, though.
Right, that's a little scary.
Yeah, it's more about augmenting their expertise, providing them with another tool.
A second opinion?
Yeah, and the studies that this paper talks about, they actually show that these reasoning LLMs can significantly improve diagnostic accuracy.
Especially in those really complex cases where it's hard to pinpoint what's going on.
Exactly, yeah.
But, we've talked about the technical challenges, but any powerful technology, it comes with risks, right? What about those bigger picture impacts on society?
Yeah, you have to consider that, and job displacement is a big one. As these reasoning LLMs get more capable, they could start automating tasks that currently require, human intelligence.
And not just those blue-collar jobs either.
Right, exactly. White-collar, highly skilled jobs could be disrupted too. It's a real concern.
Are we all going to be out of work?
I wouldn't say that, but it's definitely something we need to be prepared for. We need to think about reskilling, upskilling the workforce, maybe even rethink how we structure our economy. These are conversations we need to be having now.
It's a lot to wrap our heads around.
It is.
So should we be afraid of these reasoning LLMs?
I don't think fear is the answer. What's important is cautious optimism, a sense of responsibility. These are powerful tools, and like any tool, they can be used for good or for bad. It's really up to us to steer things in the right direction.
Guide them, yeah.
Yeah, guide them.
All right, so let's shift gears a bit. We talked about those aha moments earlier, those flashes of insight that these LLMs seem to have. Is there any way to understand what's going on inside their, artificial brains when that happens?
That's the million-dollar question, and it's something that researchers are trying to figure out. This paper mentions some really fascinating techniques.
Like what?
Like attention visualization and activation analysis. Basically, trying to peek inside that black box.
Attention visualization, activation analysis, those sound intense. Break those down for us. What are those techniques all about?
Well, essentially, they're ways to visualize what's happening inside the neural network.
Kind of like creating a map of the AI's thought process.
Yeah, exactly. We're not quite there yet, but we're starting to get some clues.
Like what kind of clues?
Well, one study found that during an aha moment, there's this burst of activity in a specific part of the model's neural network, like a little light bulb goes off.
And that region, it's linked to those higher level thinking skills like planning and abstract thought.
Exactly. So it's not just processing data. It seems like it's actually engaging in something that's closer to, human thought.
So it can actually think in some way.
It seems that way, which raises even bigger questions. If an AI can have those aha moments, can it be conscious? Truly creative? Those are big questions.
That's getting philosophical.
It is, right? It's pretty amazing, though, that we've created machines that are making us rethink the nature of intelligence, even if it's a bit unsettling.
Well, I think we need to move on to something a little less mind-bending. For now, talk about those practical applications that are already shaping our world. And of course, we can't ignore those ethical considerations that come with such powerful technology.
That's a perfect segue into the next part of our deep dive. Stick with us, folks.
Okay, so we've talked about the inner workings of these reasoning LLMs, how they're built, how they learn. We even touched on their potential to revolutionize fields like science and medicine. But now I want to zero in on what's already happening. How these models are actually changing the world right now.
Yeah, let's bring it down to earth a bit, because sometimes it's easy to get lost in those what-ifs and forget that these advancements are already having a real impact.
Exactly. So let's talk about some real-world applications. And I want to start with something I think a lot of folks can relate to, even if they're not AI experts, code generation.
Ah, yes. This is a big one. Companies are already using these reasoning LLMs to automate, chunks of the software development process.
So instead of programmers slaving away over every line of code, these LLMs can generate whole blocks of code based on just a few instructions. It's like having an AI coding buddy.
That's a great way to put it. And it's not just about speed. These models can often generate more robust code, fewer errors, especially for those really repetitive or complex tasks that make programmers want to tear their hair out.
I can imagine. So it's like having an AI colleague who never gets tired or makes typos. Sign me up.
Right. And the implications for the software industry are huge.
Right.
Faster development cycles, fewer bugs, potentially even lower costs.
So it's a win-win for everyone, except maybe those programmers who really love debugging.
Well, there's always going to be new challenges, right?
That's true.
It's not about replacing programmers. It's about, augmenting their abilities, freeing them up to tackle those more creative and strategic tasks.
Exactly. So it's a collaboration, human and AI working together. And this augmentation isn't just limited to coding, right? Another area where we're seeing big changes is customer service. Think chatbots, but way smarter chatbots.
Oh yeah, those old school chatbots, the ones that can barely understand a simple question, they're going extinct.
They're frustrating.
Yeah, but these reasoning LLMs, they're taking chatbots to a whole new level. We're talking about chatbots that can understand your problem, reason through different solutions, and actually provide helpful assistance.
So it's like having a real conversation, with a knowledgeable customer service rep, but without the hold music.
That's the idea, and some of these advanced models, they can even pick up on human emotions.
So they can sense if you're frustrated, if you're happy.
Yeah, and that tailor their responses accordingly. It's pretty amazing.
It is amazing, but it also kind of blurs the lines, between AI and real human interaction.
It does, which brings up some really important ethical considerations. Because as these reasoning LLMs become more powerful, more integrated into our lives, we have to think about the risks.
Right, we talked about job displacement earlier, but there are other ethical concerns that are specific to these types of models, and the paper talks about transparency as a big one.
Transparency is crucial, because these models are trained on so much data, it can be hard to understand how they're making decisions.
Right, it's like that black box problem. You feed in data, you get out an answer, but you don't know what happened in between.
Exactly, and that raises questions about accountability. If an AI makes a decision that has negative consequences, who's responsible?
That's a tough question, and it's not just about blame, it's about trust. If we're going to rely on these AIs to make important decisions, we need to be able to understand how they're thinking.
Right. We need to be able to trust their reasoning process, and this is an active area of research.
So there are people working on ways to open up that black box, make those models more transparent.
Exactly. And that's going to be key to building trust and ensuring that these models are used responsibly. But transparency is just one piece of the ethical puzzle.
So what else do we need to be thinking about?
Well, fairness is a big one. Even if you eliminate bias from the training data, there's still the question of how these models are actually used.
Right. Who benefits from them, who's left out?
Exactly. And this requires a much broader conversation. It's not just technologists, it's ethicists, policymakers, the public at large. Everyone needs to be involved.
Because this is going to affect all of us.
Yeah.
The future of AI is something we're all creating together.
Well said. And it's a future that could be incredibly positive. You know, we've talked about the potential to revolutionize science, to improve healthcare, to make our lives easier in countless ways.
Well, we got to be proactive, address those risks, make sure this technology is used for good.
That's the key. The future of AI is not set in stone. It's something we're actively shaping. The choices we make today will determine what that future looks like.
That's a great way to wrap things up. So to all our listeners out there, keep asking those questions, keep pushing those boundaries, because the future of AI is in our hands.
Let's make it a good one.